we were talking earlier, this is one of the only other places in the country dedicated to this notion of environmental design, which we're not even quite sure what it is, but it's something, it's based on a kind of curiosity and courage about the connections between these professions that have grown up with their own cultures and histories over time, architecture, landscape architecture, planning, and have, if you notice, I pay attention to clothing. People in those professions dress very differently. Architects tend to wear black and chunky glasses. Landscape architects are kind of on that spectrum, but they tend to throw in other colors, more earth tones, to like the elves of the Lord of the Rings, to show that they're on the side of the trees as well. And then you have planners who tend to affect the more kind of academic, tweedy look because they're holders of a certain kind of expertise. And what all those things are, when you see something like clothing, what you're seeing are cultures, and cultures being shaped. And yet our professions are not about the cultures of our professions, although of course they are that. But they're also about this large, but also in some ways very small planet that we share, and all of the opportunities and difficulties that shared planet presents us with. So the notion of environmental design is a kind of an assertion, a lateral assertion across those professions, that we have more in common with each other than we do with the world at large, and we should stick together. And yet, I mean, the French and the English have more in common with each other than they do with the rest of the world. And they're not very good at cooperating at all. Sometimes the people who have the least success in cooperating with are the people who are most like us. Try to make either a French or just tell a French or an English person that they have something in common with the French or the English respectively, and you will see precisely how difficult it is often to get people who have a shared history but are not quite together to engage each other. So all of that is a very long-winded way of saying I'm excited to be here at another institution of environmental design, and I'm excited to try and talk to you a little bit about ideas in my own practice as a scholar, as a designer and a maker that have been somewhat transgressive of these disciplinary boundaries, and I would hope all the more useful for it. So the next 5 slides will be interesting and humorous only to those of you born before 1990, but it used to be the case when I was an architecture student, we got these lecturers in, and they would come with slides in 3-ring binders, and they would put them into 2 carousels. Ever since Wolflin and the Warburg Institute of the late 19th and early 20th century started showing 2 lantern slides next to each other. It was the case for years and years. You just had 2 slides next to each other. And where I went to architecture school at Princeton in the 90s, you would get this like a little bit of architecture theory and then some design. So Greg then would come and talk about Lefebvre and folding, and then show you a bunch of renderings that were painstakingly printed from the computer screen onto 35mm slides. I don't know how many lectures you have now, but architectural lectures, at least in my school, often look like this. Like the talk about like the establishment of architectural culture, the designer is sitting here right up until the last minute, throwing all these slides into the PowerPoint. You can see them on the screen, and then they come, and it's just like 100 slides, and all the ideas that connect them. I'm going to try and do something a little bit differently. I guess the thing that most defines my own practice is the fact that I love tools. I really do like tools, as my wife sometimes notices on her credit card bill. But things that allow you to make things are some of the most magical things in the world, because they kind of allow you, just like the wand in the Harry Potter movies, or to do something that you simply would not be able to do otherwise. Ideas are also tools. I guess this is one of the fundamental things that I'm going to try and explain to you tonight. And one of the things that I believe, as architects, we are, and designers in the environment, that we need to be as facile with the tools of ideas as we are with the tools of a CNC router or even just a chisel. Not because there's any particular prestige involved, different prestige involved with the world of ideas as is necessarily involved with the world of X-Acto blades, but because both those tools are very powerful in what they let you do. a blade or a router lets you make something you wouldn't be able to make otherwise, and a structure of ideas allows you to think your way to possibilities that would never be otherwise visible to you. So, and these two things together have, in design practice since the Renaissance, helped each other. Sometimes we invent tools that don't exist because our ideas tell us that they're needed. Sometimes we push our ideas because the tools that we use lead in a direction that we are into some kind of uncharted territory, and we need to map that territory intellectually. Okay. So, I found it useful in the start of presenting the work that I'm going to show you tonight, which is a set of ideas about how we, digital tools in the city and urban design and how we think about them. I found it particularly useful, funnily enough, to start far away from the earth with the book, the writing of which actually led me into the work that I'm going to show you tonight. And the book, as was explained rather beautifully in the introduction, was a history of the Apollo spacesuit. Why on earth might one, or should one, be interested in something as seemingly unrelated to the everyday practice of architecture as the clothing worn by Armstrong and Aldrin on the surface of the moon? Well, it starts with the devil, this guy. When John Milton wrote Paradise Lost, he needed a name for the space in between worlds. And so he invented a new word to describe that space, which was capital S space, which is very different from the space that you and I are journeying through. In fact, it's defined by its opposite, by its very difference from that space. So capital S space is, from Milton onwards, inhabited by celestial beings, perhaps, but is very hostile to human occupation. Ever since, however, humans and a lot of Americans have journeyed into space across the boundary between lower S space and capital S space. Space has been defined most of all as one thing, which is the space that we need, the environment that we need technology in order to enter. And so for all kinds of different disciplines, that has a different altitude number. For rocket engineers, it's where you no longer need wings. For doctors, however, it's the lowest of all, 37,000 feet. I felt the difference coming to your fine elevated state today, 10,000 feet from Berkeley, because I was a quarter of the way to something called the Armstrong line, which is where blood boils at body temperature, which is 37,000 feet. Anywhere above that is space for a doctor. So if space is defined as the situation that we need technology in order to enter, it might be the case, what I'm going to kind of argue to you, that if we go all the way 250,000 miles to the surface of the moon to look at this most extended and most intimate kind of environment, the spacesuit worn by Armstrong and Aldrin on the surface of the moon, we might find out something interesting not only about this environment, but about our environment and space here on Earth. Now, this is not actually an original thought. The great New Yorker critic and urbanist Lewis Mumford opened his book, 1960 book, The Pentagon of Power, all about cities and in many ways how terrible they are, which is a terrible thing for an urban critic to be writing, with this picture of Gus Grissom in his Gemini spacesuit. And he said Grissom was a quote-unquote powerless embryo in the embrace of technology. I'm going to tell you a slightly different story, but not too different. It certainly is the case, as Mumford knew, and he was arguing in the book, that the giant architectural apparatus of technology that was taking mankind into space was mostly one designed to kill people. And it came from an enormous complex of companies and theories and engineering connections that created that enormous space program, came from a very particular origin, from the building of the first intercontinental ballistic missiles in the early 1950s. And that the Convair company, which was a military contractor, tried to build by ordinary means, just like they built bombers and planes beforehand, and they had a particular problem, which is that they kept blowing up. And they kept blowing up for all kinds of different unexpected reasons, like the resonant frequency of the fuel pump in the bottom of the rocket was the same rather, as the resonant frequency of the gyroscope in the top of the rocket, and so they canceled each other out and blew up. And there are a million other niggly little things which, for anyone who's used technology in the last 24 hours, comes as no surprise. Technology always breaks in unexpected ways when unexpected things influence each other. But what it meant was a new kind of engineering and a new kind of way of looking at the world. When, in the report to the Joint Chiefs of Staff, proposing a program associated with this ICBM program for missile defense, the author of the report, Georgie Valley, used the word system in explaining to the Joint Chiefs of Staff this new approach to the world. The word system was so unusual in the English language that he had to provide a page-long definition. Just think about that for a second. How many systems have you encountered today? Well, in the report at the time, it said, well, it's like the solar system, or like the New York State Railroad system. It's a collection of objects, not so much defined by themselves, but defined by their relationship to each other. And so systems engineering very successfully produced the first ICBMs by defining the problem not as the construction of giant aircraft, but as the construction of a whole bunch of systems. You might have heard the phrase black boxes. This was another phrase invented at the time that were defined not so much by what was inside of them, but by their relationships to other parts of the system. So the propulsion system could be given to one contractor, and the navigation system could be given to the other contractor, and they were all defined by their connections to each other. One thing we got out of this was a gigantic arms race, because if things were defined as a system, now I know none of you feel like you have to upgrade your phones on a regular basis, but imagine for a moment if you did. Your phones are part of the telecommunications system, and because they're defined as parts of that system, they can constantly be upgraded to a larger screen or better transmission, better battery life, maybe sometimes worse battery life as they get thinner and thinner. But either way, once you've explained everything as a system, you can swap out all the parts of the system, right? So the arms race was a very natural consequence of this, because the Russians could make their rockets go a little bit higher, and we could upgrade our propulsion system and upgrade our megatonnage, et cetera, et cetera. Dwight Eisenhower got so freaked out at this, at the way in which this huge combination of military contractors and the armed forces and institutions like this one collaborated to make a lot of money constantly upgrading these systems, that he devoted his last speech to the American people, if you can imagine such a thing, to warn of the effects of what he was the first to call the military-industrial complex on our national society. And he actually wanted to call it the military-industrial academic complex, but his speechwriter said that that was too long. But institutions like this one are very, very much part of it. But let's come back to the human body. The very first proposal as to about how to get humans into space flowed very directly from this systems engineering approach. It also had a new idea associated with it. This was not so much the idea of the system, although it was implicit, but it was a new word invented for this called the cyborg. How many of you ever watched Star Trek? I know I have, right? So those nasty people with systems going into them, technological systems going into them. Those are the Borg, which is entomologically derived directly from this word invented by a psychopharmacologist and an expert in analog computing in 1958 for the Air Force to describe or imagine how human beings would be made like angels and go into this capital S space by, they proposed, swapping out all the bits of our own systems that were inadequate to being in space, so giving us a new skin or a new kidney or a new heart that was better able to deal with the hostility of this environment. After the Sputnik, the Russian launch of the Sputnik satellite and the sudden space race, again part of the Cold War with the Soviet Union, the cyborg concept, millions of dollars were spent on it, but it was determined not to be ready in the time frame available, and so instead there were these hard kind of one-piece suits of armor that the NASA advertised with press releases like "nothing new under ye old sun," which sort of cast American astronauts, and they were all men, of course, as these kind of warriors of the space age. But what actually happened was something quite different. Instead of being made as hard one-piece suits, spacesuits were soft and multi-layered. Instead of fulfilling a kind of masculine stereotype, they were made by the Playtex Bra and Girdle Company, then famous not so much for its line of bras than for its rubber foundation garments. And instead of being engineered from first principles, the suits were hand-stitched by female garment workers taken from the regular Playtex assembly line. Now, for this to happen, of course, other proposals needed to fail, and fail somewhat spectacularly, and they did. And even then, the process of translation between these ladies and their brushes and sewing machines and the larger complex of systems engineering were very extreme. First of all, I'll give you two examples. First of all, instead of when in a systems engineering process you change anything, it gets a new serial number. This is very important for making all those systems interrelate with each other. But when you're designing to the human body, you're changing stuff all the time. You're stitching a little bit here, you're letting a seam out, you're adjusting, you're adapting. And so after a huge multi-year battle, Playtex won the right to, instead of serialize with all these different numbers, all of these different spacesuit parts, they could call each of the parts of the body a small, medium, or large, like each part of the suit, a small, medium, or large, like clothing. And that's how it was done in the administration process, except for the urinary collection device, which after an incident with the first astronaut fitted was sized large, extra large, extra, extra large. True story. The second kind of difficulty in translation related very much to a lot of what architects and landscape architects certainly do, which is how things were drawn. It was drawn, as it were, to Playtex's attention that it was part of their contract in NASA that they needed to supply a drawing of the suit and how it was made. But there was one big problem. There were no drawings. The suit was only made with a series of patterns or cutouts of all the different parts, and then what were called tables of operations, or kind of lists of instructions, like a recipe, that basically served as guidelines for the seamstresses in applying the craft, sewing to 1/64 of an inch tolerance, only on one side of the seam and without pins. The pins would puncture the suit. So after the successful launch of Apollo 11, when there was some time for such things, the drawings were produced, but they were produced as the result of a dissection of the suits, which is to say the suits were taken apart, and a bunch of people were tasked with drawing how they were made, but the drawings weren't made like an architecture drawing in advance of the thing being made, but they were rather made to try and understand it after the fact, which means that they have a lot more in common, for example, with Nolli's famous map of Rome, which kind of dissected the public space of the city as it was built, than they did with a conventional architectural drawing. And I guess one of the points that I'm trying to make here, 250,000 miles away from the Earth, is that technology, who by definition defines this capital S space, even as it allows us to be like Milton's angels, it also tends to collapse as it gets closer to the body. So this spacesuit, which was a miraculous technological object, also had, unlike all the rockets and ICBM parts outside here, this surface had as much to do with the way in which that body inside was organized as it did with the larger systems of the military-industrial complex of which it was also a part, even down to its organizational logic, which was epidermal, that is to say multi-layered and adaptive, and little parts could fail, which was a lot more like human skin than it was, say, like the skin of the rocket. So, I want to introduce one other word here, which I think is an important one, which is the word media, which comes to us from the Latin. It means a little element or lens. It's the thing that comes in between you and something else. So the spacesuit is also a really interesting object in that it is literally a media. It came between the body and outer space and allowed it to survive in the lunar vacuum. But it also was an essential instrument in the ultimate product of the space race, which we often forget, which was not, even though your science teacher told you this, the rocks that we brought from the moon or some kind of new sense of discovery, although that was of course great too. The real product of all of this was, very appropriately to our own age, an entirely ephemeral image. It was by producing a television picture of an American on the surface of the moon that the great battle of the Cold War was fought. We are, of course, in an age increasingly defined not so much by objects as by media, or certainly about the interrelationship between objects and media. Okay, how many people in the room have their phone on vibrate? Right, but it's on, right? Because you're that generation, right? So, and you probably even felt while I'm talking to you here, there's some messages coming in. Some of you may have been able to control your anxiety enough not to check. Some of you maybe have. I saw you in the back looking at the phones to see if anything urgent is interrupting the lecture. Just think about this for a minute. We are very much in a world where this thing, intimately, caressingly against your physical body, is buzzing to tell you that a server somewhere has just received a message for you and is wirelessly beaming that signal to you, and you don't bat an eye at the way in which the physical reality of this room is completely dissolved. And there are thousands of other potential voices speaking to you along with mine, which is a lot of competition. I'm fine with that. But it's also a way of saying, as people who think about the environment, I think we need fundamentally to understand in the ways in which transformations of media are shaping not only our world, but actually our disciplines. So one way to trace this would be to look. I just told you this story. You may have thought it was a fun story, but you probably thought it didn't necessarily have a lot to do with what you were doing earlier today, which is probably sitting in front of a computer, maybe designing something, certainly typing or using symbols. But in fact, I would tell you the story that almost everything to do with those tools and those media, of design in particular, have to do with this particular moment in history, and have embedded in them all the ideas of that time and that place. Something as simple as the very first interface. Computers, up until the missile defense system, in which that word system was used for the first time, computers were just things that sat there and spat out calculations. They did batch processes. You put in a bunch of cards, waited till the morning, and then a couple of answers came out if you were lucky. But the notion of interacting with a computer in real time was invented to allow this Air Force officer with a light gun to shoot down Soviet airplanes. All kinds of things had to be invented for that to happen. Something as insignificant as RAM, right? Memory that can be used dynamically instead of statically. The very first three-dimensional spatial simulations. This is the very first three-dimensional computer-generated landscape ever encountered by human beings. It was the Lunar landing simulator invented by General Electric. And it could only display 256 edges, so even though it doesn't look like the surface of the moon, it was coding for that in the color of those crosses and things. But that's not even, we don't even have to look to some kind of conceptual connection either between these computer tools from the Jurassic era and what we do, because it's also true that almost immediately after they were invented, all these tools were suddenly used or trumpeted as the solution to all of our problems with the other big problem of America in the 1960s, the quote-unquote city. So Vice President Hubert Humphrey announced in 1968 that the very same technologies that brought us to the surface of the moon were going to solve the problem of the American city. And of course, like any politician, he was taking credit for something that was already happening. There were already all these summer schools between NASA and HUD in various places. That lunar landing simulator was used only 2 years after it was invented by Peter Kavitzer of the architectural school at UCLA to prototype these high modernist proposals for downtown LA with skyscrapers and piloti, and you could steer through them with the joystick of the lunar lander, which I'm sure would have been really fun. The guy who invented this spaceship might look a little familiar to you. It was a prototype deep space nuclear-propelled spaceship invented by a guy named Howard Finger for NASA. He was NASA's director of nuclear propulsion research back when such a thing existed. In 1968, he became the first director of research for the new Department of Housing and Urban Development, where he pioneered all kinds of programs applying space technologies to the city. In particular, something called, the biggest of which was called Operation Breakthrough. Now I don't have to, maybe you know, maybe you don't know, maybe you can guess. You know, who here thinks that the process of designing cities with space technology worked out really well? Who here thinks it might not have worked out so well? Okay, I want to point out to you, that's so interesting that you know that, right? Our lives are defined by technology, and you know that, however, instinctively, that the application of a kind of broad, grand, trumpeted technological solution to something as messy and real as the city is not likely to be necessarily successful. And that certainly was the case, because this program, Operation Breakthrough, was actually cited by the General Accounting Office for not meeting any of its demands, and for where the project, any of its grand plans, and when the proposals were implemented, they tend to be plagued by problems that are as, you know, were as expected, potentially by you, as they were unexpected by their designers, like the sophisticated pneumatic trash system in the Jersey City Operation Breakthrough site that operated very well, but in the reverse direction which it was intended. Everyone's apartments got full of trash. So maybe the last best image of these proposals is this, a space station invented by NASA's Ames Research Center in 1975 between the Earth and the Moon, that was designed, that used all of these prefabricated housing models that were developed for Operation Breakthrough to picture the housing of 10,000 astronauts, optimized by age and gender, and settled by persons from Western industrialized nations. And I would say that here, this sort of totalizing system idea is seen maybe in its own only native soil, which is to say a perfectly managed utopia entirely subject to principles from government and industry. So this would all be funny and a kind of cute historical detour if the effects of this moment of history weren't deeply embedded in our tools today, and even having somewhat of a renaissance with the vast decrease in cost of processing power now on the desk of any planner, designer, or public official. Let's take a simple, something as simple as this tool. None of you probably recognize this tool, but it used to be, when there was one computer on a campus like this one, that in order to write a program on it, you actually wrote the program. That is to say, you separately typed it up and brought it over to the computer center to work. And to work out the logic, the steps of your program, the nice people at IBM who wanted you to be able to use the computer would send you for free one of these things, which was a template for a flowchart diagram. You might have seen flowcharts like this in PowerPoint, because PowerPoint, not coincidentally, has all these shapes in it as well. But the flowchart let you figure out what you were doing with your program before you actually got it to the computer. The flowchart was used to program programs like this one, part of the Section 1 redevelopment clearance apparatus, research in part at the University of Washington by a guy named Edgar Horwood, when if this, then that statements helped you figure out which blocks you needed to demolish. The program, this is one of the first computer mapping programs used by planners, had to be, how many of you use like the architecture software Grasshopper? Some of you. It's still the same kind of logic, if this, then that, graphically represented. So you had to do this in order to figure out the program, but it was only, and then the author of this program started publishing diagrams like this one, which was not necessarily a program diagram, but used the same logic to say, this is the steps in designing a map. If you do this, then you do that. If you do this, then you do that. Classic systems engineering. This was the kinds of maps that were produced very artfully, hacking the typewriters at the time, computer typewriters, to produce maps with by overprinting lots of characters. And then, almost seamlessly, you have diagrams like this one, which is how to design a city, from only a year later, as a set of similar flow diagrams. And those of you who use, how many of you use ArcMap, GIS? Some of you here? You'll recognize all the tools within ArcMap, because they're actually derived from that first program I showed you, have the same logic within them. If this, then that. If this, then that. Which is a direct systems engineering approach. It didn't exist. You define a problem by the relationship between a set of variables. So that's one kind of tool. The other reason, one kind of way in which this logic makes its way into present-day practice. Another way is in projects like this one. So this is Masdar City, designed by Norman Foster and partners. The idea of an entire, we are surrounded today, those of you who are in the planning discipline, urban disciplines, by talk about the so-called smart city, and by a renaissance in sales to cities by companies like IBM selling control rooms to cities like Rio de Janeiro that take all the information from the city in. This is their great promise, and let you sit in the middle like a James Bond villain and press buttons and control everything that happens in the city outward. So that's the notion, one notion of the smart city. We also have a kind of a so-called parametric urbanism, which is ebbed and flowed, the idea that you just use parametric tools like Grasshopper at the urban scale, and if it gives you a particular kind of curve between two blocks, and that curve is somehow locally sited or spaced in that city. And I would argue that both of these logics, even though they kind of look different geometrically, are the same kind of logic as we were talking about in the context of the history of space travel, which is to say, the logic of the all-encompassing system. We can only get the variables right. If we can only get the relationships right, we can solve any problems. Okay, so all I've done so far tonight is is be a critic, which is a very important thing to be. Some of our most important contributors to the world of the design and environment, like Jane Jacobs, were only ever critics. They told us why things didn't work, why things should be the way they should be. But I'm not standing up in front of you this evening only as a critic. I'm also a designer, and as a designer, as an architect, it is incumbent upon you, after you launch a critique of the way things are done, to propose a way that things might be done differently, and to not only propose it, but actually show it in the work that you've done. So I'm going to take the risk of showing you some of my own work and some of my own thinking, informed by these thoughts that I gave you earlier. My own thinking is, as I think any rational designer is thinking these days, is predicated on the fact that today, right now, and I'm speaking to you here as students, is the most exciting and the scariest time to be a designer of the built environment, as has ever been the case in all of human history. And this is not just some sort of hyperbolic statement, it's based on two simple facts, which are the core of my own practice and my own thinking about these issues. The first of these is that we are building as much urban fabric in the next 35 years as we have in all of human history till 2010. So we're building, again, as much stuff in the next generation, in your careers, basically, as we have ever before. So, on the other hand, the ways in which all those things, some people hear that and they're like, wow, what a great time to be an architect. But most of the urban fabric that we make in the next 35 years won't necessarily be made according to a traditional architectural model. There'll be no designers hired. There'll be no ribbon cutting. This is going to be a vast urban explosion at a planetary scale. And it's happening at the same time as our cities are facing increasing uncertainty and unpredictable hazards, mostly caused by anthropogenic climate change. I guess the last fact, so it's 3 facts, not 2, is the fact that even as all this is happening, as we're building out this huge extra city in human history, and we're building it out at a time of particular challenges for the built environment, we also have more data about our environment than we ever have before. We collect as much information now, or as much data, every 48 hours as we did in all of human history up until 2007. And most of that data is increasingly, as every photograph you take with your phone, tagged to a specific place in the world. Now, most of that data is just incredibly boring. Everyone's Twitter feeds, your Snapchat chats that I promise you are being collected somewhere, even if you don't think that they are. A lot of this is just dross. Data is not on its own knowledge. But most of what we do as designers, and this relates to the larger questions of pedagogy and how we should teach and learn design in this moment of history, most of what we do as designers has flipped within the space of a decade to never having enough information about the situation that you're trying to design for, to always having too much information, but never exactly the information that you need. So I would argue that this shift also carries with it its own kinds of challenges and opportunities. The particular challenge that I think about is how to build what is widely called resilience into our urban environments. And resilience, I believe in always, if you don't understand something, look up where the words came from. They'll tell you most of what you need to know. It's like the oldest intellectual parlor trick in the book. But resilience comes from the Latin for springy, for the behavior of rubber, which implies both kind of springing back, but also it implies coming back to the same shape as you were before, which is not necessarily how anything recovers from natural disaster or catastrophe. A word I like better, it comes from the Latin root word for oak, like my native Oakland these days, is robustness, is maybe another good word that people sometimes use. Robustness implies not just an ability to withstand things, but an ability to grow and change over time. But whichever word you choose, I would argue that this is the fundamental design task of our, especially at the scale of the larger human environment of our age. So the work I've been doing in the last few years is focused on this issue of media. This is, I do other things as an architect. This is an example of a gallery installation, that collaboration with the cartoonist Dan Close. It also thinks about media and environments. But the work I'm going to show you tonight is mostly focused at the level of city and at the level of data. And it started as a mostly intellectual project and case study, and it is ever more, these days, for better or worse, getting ever more towards implementation. And it started with a particular interest of mine in the work of the architect, artist Gordon Matta-Clark, who between 1971 and 1973 assembled the titles to only about 14 small vacant parcels across the fabric of New York City. And he was still kind of deciding what he wanted to do with this collection at the time of his death in 1978. Today, with a geographic information system, like I'm sure you have here, it's possible to find thousands of similar sites in just a few minutes, if you know what you're looking for. And it's not just true in New York, it's true in San Francisco, in Boston, in Miami, anywhere you look, especially in the United States, there's a kind of confluence of vacant and underutilized urban parcels specifically around highways and poor neighborhoods. And this confluence has particular properties. These are the sites that I and my students and collaborators started looking at in San Francisco about 5 years ago. These are so-called unaccepted streets, which are zoned as rights-of-way by the city of San Francisco, but not actually used as rights-of-way by the city. If you look at other kinds of urban data, you see some particularly interesting properties of these sites that are true also across the boards of similar sites elsewhere. They tend to be focused in areas with very low public health, poor and underserved neighborhoods. They tend to be in areas with high reported crime. They tend to, in fact, according to a whole set of social and environmental factors, be in very challenged areas. If you look conversely at the physical environment of the city, you see they coincide almost exactly with urban heat islands, with impedances in the stormwater system, which is especially important in San Francisco, with all the rain coming in 1 or 2 months. They line up with pollution, et cetera, et cetera. Now, this is not actually rocket science. Of course, vacant lots tend to accumulate in poor neighborhoods, and poor neighborhoods have poor public health and poor access to parks and the physical environment. This is not, many people have pointed this out. But what is now possible to do today with the kinds of digital simulation tools we have at our disposal is to make the argument, which most of the work that I'm showing you here is fundamentally making, that the infrastructural spending that we classically spend on big things, big companies building big dams and big levees, especially in cities like San Francisco and Los Angeles, that money would be far better spent on each of these individual sites where, again, using these tools, we can forecast precisely the benefit of not only the individual work on each individual site, but also the benefit, the even greater benefit that all these sites have together working as a network. So, since this case study in San Francisco, we've worked on this kind of theoretical case study in San Francisco, cooperation with a nonprofit around sites underneath billboards at the LA River, and a larger collaboration in New York. All the same social and environmental factors are true of the vacant sites in these cities, both in terms of poverty, public health, heat islands, and stormwater impedances. And again, work on these sites is not necessarily new. It's been going on for many years, but what our work does quite differently is it uses the combination of parametric design software and geographic information systems to make very specific proposals for each site. And increasingly also a more substantial collaboration with a set of nonprofits and ecological scientists at the New School, looking at 30,000 sites in New York City that these collaborators at the New School have found and mapped out the benefits for. This work is coming out in a book this October, if I finish it this month, which I'm desperately trying to. The book has 3,659 drawings in it. I'm collaborating with a really great data-driven graphic design firm in the Netherlands called Catalog Tree. And the book is really about my attempts over the last 3 or 4 years to solve one of the main puzzles of this project, which is the puzzle of representation. Of course, all we do as designers is make representations. How many of you in your Intro to Architecture syllabus had Robert Evans' essay, Translations from Drawing to Building? Ring a bell with any of you? It's often the feature of introductory architecture syllabuses because it's the attempt by a very clever British architectural theorists to point out to architects that all they make is drawings. I don't know how many of you have had architectural internships or landscape architectural internships, but if you try to go to one of your building sites or one of your landscape construction sites and you pick up a hammer and start going at it, what will happen to you? You'll be stopped and probably escorted from the site. So in fact, ever since the word design, do you guys know where the word design comes from? This is again one of these intellectual parlor tricks. The word design tells you a lot, because if you look at the origin of the word design, it actually comes from the Italian disegno, which is to draw out a problem, to represent it. So most of what we do, I know you signed up for building buildings and building landscapes and building cities, but most of what you do is create media that other people use, that influence other people to make them. So the problem of media. Now, my problem in trying to draw 3,659 separate design proposals is very precisely that I do not want to come off as a megalomaniacal architect telling people in some of the poorest and most underserved neighborhoods of American cities that they need to build all my park benches and playground structures exactly where I say they should be if they know what's good for them. In fact, one of the huge unsolved puzzles of this work that we're trying to look at with research now is how you might go about engaging large communities of large cities with many thousands of individual proposals at the same time. So it took what the drawings in the book actually do then is they is that this is an installation of the 1,500 drawings of the sites in San Francisco that I had to pin up all at once to try and understand this. But what the drawings actually do is that they don't actually show the designs. There were a bunch of physical designs that were done for all of these sites, but what the drawings do instead is show and model the effects of these designs on the environment of the city, on stormwater flow, on heat islands, on all the things that we can accurately and very specifically measure with data. And the design itself is left absent with the idea that whatever you did in these sites would have to be informed by the communities that these sites would serve, but would be funded by this particular environmental effect that we can be very precise about. So it's a combination of precision and imprecision in the drawings. And then my great collaborators at the Design Practice Catalog Tree are scripting the layout of the book so that the position of each of these designs in the city and the scale of their influence and effect controls the layout on the page. So, as I said, we're moving a little bit towards implementation, certainly with some case study projects in New York. A much more, I will talk a little bit before I end though about software itself as a project. So this is an open source, this is the case study in New York. That's one product of the work. One of the other big products of the work is an open source software library. Now, just to get super technical with you for a minute, one of the things that my ideas, my frustrations, or curiosity about designing with data for the city led me to want to do was to be able to connect these huge databases of urban data that we have that are called GIS with these very sophisticated and powerful design tools we have, whether in a BIM package like Revit or something like Rhino and Grasshopper, with these parametric tools that can do amazing things for you based on data. But it turns out, before we did this work, there was no way to systematically connect GIS data to parametric design tools. We had the software didn't exist, we had to write it ourselves. Now there are ways to bring in GIS layers as big underlays in architectural drawings, but there's no way to be able to access specific data about each site and have the computer do different actions based on the individual data on each site. The software wasn't that complicated to write, but it had to be written in order to be able to do the work, and that's part of what can happen with architecture inside a research university that can't necessarily happen elsewhere. And interestingly enough, as is in the matter of software, once the software was built, it can be adapted for a number of different kinds of uses. So one project that we did this past summer, using the same code base that produced the work that we've shown, was a collaboration with Slum Dwellers International, which is a huge global NGO, mostly but local people, now increasingly doing data collection in informal settlements as a way to lobby for their own needs in policy debates. We collaborated with them and with a set of urban theorists at the Santa Fe Institute who've done basically a new and effective kind of mathematically based model for how infrastructure can be brought into informal settlements. One of the major problems, the kind of state of the art in informal neighborhoods these days is not knocking them down, but upgrading them, putting in infrastructure, putting in water, putting in sewers, etc., connecting the home-built infrastructure of these informal neighborhoods to the larger neighborhoods of the city. To do this, though, you have to knock down houses because it's a quality of all developed cities that every parcel has an access to a road where the pipes come in, and there's a quality of informal settlements that almost no parcels, that a lot of parcels don't have access to roads. The usual result is to declare that a bunch of houses need to be knocked down. The tool we produced allows these local communities doing data collection to, this is a little animation that shows you that all developed cities are identical topologically. So that's Las Vegas, New York, Prague, all have the same number of lots with access to the street. So that's now a tool that's online. Also a collaboration with the San Francisco mapping design firm Stamen to produce the interface that now people are, lots of local communities doing data collection around the world are using to evaluate the plans proposed by the cities around them. I'm going to end here. There's some more stuff I can talk about, and we'll see what comes up in the questions. But I would just explain before I end that I think the most important takeaway from where I began to where I end is this word that I used as the subtitle of the book about spacesuits, which is fashion, which is a word that I love because it simultaneously seems it seemingly broadcasts everything that a lot of people hate about design culture, that we like things that are just flashy and fashionable and of the moment. But I would argue that fashion is a very important concept because we love fashion for its ability to capture the moment. But the way in which fashion gets there is not necessarily to invent things from scratch. If you also look at the root of the word fashion, it actually just means to make something out of something else. So a spacesuit out of a girdle, for instance, or a new kind of city out of the old city instead of breaking it, demolishing it first. And it's this idea of fashioning that I think is especially important if we think of it. Now this image was one of the great artifacts of the space race. It was actually produced in 1972, 3 years after Earth Day had started using a space, an image of the whole Earth on its flag. It was produced through environmental lobbying, and the image seems to show the Earth as this big combined system, which is an idea that we like and which it symbolizes. But I would point out to you also, in terms of fashioning, and that where we really live is not in a giant sphere, but on this tiny little skin. If the atmosphere were water, it would be smaller than the Mediterranean. It would only fill up the Earth fill up the surface of the Earth about 30 feet. We live in a very small environment where our effects, whether it's carbon emissions or other environmental influences, our effects are felt quickly and enormously across all the globe. So I would argue that fashioning out of this very fragile, thin skin on the Earth that we all share is maybe one of the most important concepts we could advance as designers in this great opportunity of the next 35 years. So thank you very much for your patience tonight as I've gone through a world of both ideas and objects. I would be very happy to take questions, but I know you probably also have all kinds of studio things to do too, so feel free to take off if that's what you want to do as well. Thanks very much.